All right, we good. So this one of them weeks, right? It's pantry week, right?
Yeah.
So remembering y'all. All right, how you doing? Um, it's good. It's good. Good, good. So yeah, like if y'all haven't signed up for pantry yet, tomorrow and Thursday is your day. Like sign up and go if it's your first time. If like if it's not your first time, you know how to do your appointments and all that. Everything. Yeah. I'm sorry? Yeah, intake form. Yeah, just fill that out. It's free. Then you just walk in like if you've never done it before. Like I would recommend just do it after class. If you have class that day, go to class, then right after, boom. I believe they close at 5. I might be wrong. It might be 6. All right, but each day, Wednesday and Thursday. Mhm. Yeah. They will if it's your first time.
So
Yeah.
depends. Because
Yeah.
when there's some try to do that, it's like half a day, because it was ready to schedule for certain.
Yeah. Yeah.
So we have to get popular.
Oh. That's because I've been telling y'all about it. That's why it's popular. Yeah.
I mean, these things, I think that's free.
That's good. That's good. That's good. Yeah. Yeah. Cause I felt a certain type of way when I was a student. Like I didn't have that opportunity, so I wanted to share that with y'all. Cause I didn't know. I didn't know. Yeah. Yeah. But nobody told me that we had it at school. I thought it was just around my block and that was it. They have they have all of that. Yeah. And actually all of that is in the form when you fill out the form, right? So it'll help you out. What's up?
Man?
I got you. I got you.
I
I got you. I got you. I got you. I got you. Everybody did really good. Actually.
Everybody did really good.
Yeah. I mean, the only people that ain't passed is the ones that ain't taken yet. I mean, I don't know if everyone want their grade up, so Nah, some people be like, dang, like I got a 91. I was hoping for like 99. How you doing, man? Yeah. So yeah, it is on. Yeah. Just press the down arrow if anything. No, not yet. No. And the class, I'm gonna do that real quick. So yeah, so yeah, just to yeah, go ahead. Yeah, the lowest one. I mean, yo, if you want to drop 100, drop 100. Like. But so yeah, like I'm gonna do the test at the end, right? Check this out. Check this out. Once y'all hear this though, right? So nothing I'm gonna do with the test. I'm gonna give y'all an opportunity to improve y'all score. So if you had like a 70 or something, I know it happens. Don't say you. Yeah, look, now if you have a 70, right? I'll give you back half the points that you missed on the test if you bring it to tutor and do all the questions you got wrong with the tutor, and they get their signature. Yeah. So a 70 that's gonna turn into like an 85. Do that. Yeah. No, I tutored already. I'm done. Yeah. But not with me. Any other tutor, right? Any other tutor. Yeah. Just make sure you get their signature at the end. Okay, and then that's it. Yeah? But before we jump into today, any questions? Any questions from the homework or anything? Not the new homework, the old one. Old ones. Yeah. Yeah, everybody good? No questions? On Thursday I am, not Wednesday. Yeah, so like tomorrow I'm not. Yeah, 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 yeah. I'm not here though, that's the thing. So here's what happens, right? I have a morning class, right? So when my morning class like finishes, it's not enough time for me to travel home. So I'm here, but I'm like online for the day. Yeah. But I mean, you guys could book me online and like see me right after class if you want. It's just a different Zoom link. That's all it is. So when you book an appointment, they're gonna send you a confirmation email to say like, hey, you got an appointment at this time, blah blah blah. In that email, there's gonna be the link for the Zoom online. Yeah, yeah, I got you. Yeah, yeah. What remember the website WC Online? Yeah, that same one. Yeah, just log in. You could book right there. Yeah. So no questions from the homework. Everybody's good. We focus on other things. All right. All right. Yeah. Not from the new homework, from the old one. Yeah, yeah, yeah. Yeah, I mean, I remember tutoring is online and in person, so whatever modality works for you. Yeah, yeah, come through. Come through, man. Yeah. What's the training? Kind of heard about that. Look, yeah. That 12 bus is a long ride, I ain't gonna lie. It's a long ride. Wow. Feel you. Feel you. Back when I was a student, I used to go to co-op every single weekend because I you know Panera Bread. That's where I like to study at. So yeah, just go there. Best study spot ever. I mean, unlimited drinks, hot and cold, right? Like they got a clean bathroom. You can't beat that. Yeah, and they got Wi-Fi and they got outlets. Can't beat that. Yeah. Never been to the library. But the thing is that you can't eat in the library. Like I can eat in Panera, you know. So yeah, yeah, yeah. All right, go ahead. What you got? Three. Oh, hold on a second. So I heard 3WQ like that. Okay. Equals 0. All right. So long story short, I want to solve this equation right here. Right. Before I could solve it, gotta break it down in factor, right? What's my greatest common factor here? 3 what? 3W, right? So I'm factoring out of 3W. What's left over? I'm just like you're dividing by 3W. Dividing by 3W. Dividing by 3W. What's left over? W second. What else? Minus 5W. Good. Plus 4. Very good. Sheila follows. Yeah. W squared. So right here, you're oops. The exponents, right? So whenever we divide the variables, we subtract their powers, right? So 3 minus 1, W squared. I got you. So help me out real quick. So I got 3W. Factor this for me. Just factoring it. Right? This is gonna be W. Yeah. You got confused when you're doing it? All right. Got you, got you. So look, here's how I do this, like if I'm doing it in my head, right? I want two numbers that multiply to give me 4, but when I add them together, it will give me a -5, right? Now, I know from multiplication, the only way that I could get a positive number is if I have two positive numbers being multiplied together, or I have two negative numbers being multiplied together. But which one is this? I gotta look at my B term. My B term right here is -5, right? So because the only way I could get that kind of a number is if both the numbers are negative. So I know it's negative here and I know it's negative here. But here's the issue though, right? What two numbers multiply to give me 4 but add up to 5? They have to multiply to 4, and when I add the two numbers together, they have to add up to 5. 1 and 4. That's it. Right? Because 1 times 4, 4, 1 plus 4, 5, right? All right. After this, set each one of these equal to 0. That's it. So 3W is equal to 0. Divide by 3, divide by 3. We have W1 is equal to 0. Then I have W minus 1 is equal to 0. Add 1, add 1. So I have W is equal to 1. That's W2. And then I have W minus 4 is equal to 0. I'm going to add 4, right? Because what you do to one side, you do to the other. So W3 is equal to 4. All three of these are my answer. That's it. Yeah. So for your like your homework, you're probably gonna separate those by like a comma or something. So like 0, 1, 4, something like that. That would be it. Yeah, you got it. This is factoring. So this is actually polynomial equations. Polynomial equations. Yes, that same thing. The formula. You asked me about the general formula. Let me see if I get that for you. Got you. Give me 1 second. All right, so this is your general formula that you're asking about. Yeah. So remember what I was saying, if you use the AC method, it'll always work. Right, AC method is clutch. It'll work for everything. You know? For a trinomial. For a trinomial. All right, any more questions or are we good? All right, give me another one. Two, 2x cubed what? Equals 3x, like that? All right, so I just want to solve this, right? But I can't solve it the way it is. I got to put everything on one side, right? So I'm going to subtract this 8x from over here. What I do to one side, I got to do to the other. You subtracted the 2x cubed? I could have, but I don't like when my leading term is negative, you know? So now I have 2x cubed minus 8x is equal to 0. First things first, right? Greatest common factor. What is it? 2x, right? So when I factor out of 2x, what's left over? Minus what? 4, right? And if you're wondering how we do that, we just divide by 2x. That's how we get those numbers. Anyway. Uh-huh. If I was looking at this like how you did it, I would think I had to. I'm trying to go do the opposite, right? I'm trying to factor, right? Break it down so that it could be distributed. So x squared minus 4 No, I can factor that out, right? So help me out. What is that? X minus, no, X minus 2 and what else? No. X plus 2, right? Remember, this is the difference of two perfect squares, right? Difference means the subtraction right here, right? So you're gonna have the same number in both. One is positive, one is negative. It doesn't matter which one you put first, right? After that, same thing we just did before. You're gonna set both of these, all three of them, excuse me, equal to 0. So I have 2x is equal to 0. I'm gonna divide by 2. I do the one side, do to the other. So I have x is equal to 0, x1. x2, I'm gonna have x minus 2 is equal to 0. I'm gonna add 2 over here where I do the one side, do to the other. So x2 is equal to 2, right? Over here, I have x plus 2 is equal to 0. I'm gonna subtract 2, subtract 2. So I'm gonna have x3, excuse me, is equal to negative 2. All three of these are my answers. The first one? Oh yeah, yeah. The 2x, yeah. All right. Right. And just subtracting. So set everything equal to 0. All of the products here, individually. That's that. All right, let's do some more problems at the end if anybody has those questions. Let's look at what we're looking at today. Woo! It's gonna be fun. Good. This is what we're doing today. All right? It's gonna be lit. So we previously reviewed the properties of fractions and their operations. We introduced rational numbers, which are just fractions where the numerators and denominators are integers. In this chapter, we'll work with fractions whose numerators and denominators are polynomials. So we call this kind of expression a rational expression. So that's what we're doing right now, rational expressions. All right. I know this topic is really easy. You got to go through it. All right. So rational expression. So a rational expression is an expression of the form P over Q, where P and Q are polynomials and Q cannot equal 0. Right? Q cannot equal 0. That being said, real quick, let me show y'all some examples of rational expressions. Right here. For example, say I have negative 24 over 56. That's a rational expression. Say I have 5x over 12y. That's a rational expression. 4x plus 1 over x squared minus 9. Rational expression. 4x squared plus 3x minus 1 over 2x minus 8. Rational expression. Why is it 56? Right. See it? Why is it 24 over 56? Yeah. It is a regular fraction, but you could also consider that to be a polynomial. Right. Because, you know, I could put, for example, x to the 0 power here, and anything to the 0 power, you know, is 1. So it still holds true, you know? Yeah. Erase, I don't want to confuse y'all. All right, so let's build some vocabulary real quick before we jump into an example. All right, so we will do the same operations with rational expressions that we did with fractions. We will simplify, add, subtract, multiply, and divide them to use them in applications. Determine the values for which a rational expression is undefined. If the denominator, the bottom of the fraction, is 0, the rational expression is undefined, right? Because remember, it's illegal for us to divide by 0, right? So the numerator of the rational expression may be 0, but not the denominator. Remember that, it's really important. Alright. So real quick, let me give y'all a little bit of procedure. So this is just a little how to determine, right? The values for which a rational expression is undefined. Step one, set the denominator equal to 0. Step two, solve the equation. The same kind of polynomial thing we were doing before. That's all it is, right? Just solve it. Like, so I'm looking for which numbers would make the equation equal to 0. And that's it. Let's take a look. It's not going to be so bad. Let me change my pen real quick. Start off with the rainbow. So I got A, right? A is 8a squared b divided by 3 times c, right? Now, in this question, A and B could be whatever they want to be. I really don't care, right? That bottom part, right? I'm going to take the denominator, 3c. I'm going to set it equal to 0. And then I want to solve for c. So I'm going to divide by 3. What I do to one side, do to the other, right? So I have that c is equal to 0, right? So if they ask me which value, or if they ask me to determine the value for which the rational expression is undefined, it's undefined at c equals 0, right? Because if I plug in 0 into the denominator, that would mean I'm going to divide by 0, and that's illegal. We can't divide by 0. And that's it. That's the whole process right there. Let's take a look at B. I'm sorry? C equals 0. Yeah, C equals 0. Let's look at B. I got 4b minus 3 over 2b plus 5. Again, I really don't care about what's going on in the numerator, right? The top part. It's the bottom part that I care about, right? Which number can I plug in for B to make it illegal, right? To make it so that I'm dividing by 0. All you got to do, take the bottom part, set it equal to 0. 2b plus 5 is equal to 0. And then just solve for B. Solve for B. So what am I going to do? I'm going to subtract 5 from over here. What I do to one side, I have to do to the other. And then I'm going to have what? 2b is equal to negative 5. And then I want to divide by 2. What I do to one side, I do to the other. So what do I have? I have b is equal to negative 5 over 2. So what does that mean? That means that I could plug in any number I want into this rational expression except the negative 5 over 2, because that would make the denominator 0, right? And that's it. So what that means? Any answer could go here except this one that I'm showing y'all. Yeah. What is the point of blowing that information? So, right. Make it undefined. Yeah. Right. You're gonna find what answer is illegal, so to speak. You know? What? Illegal. Oh, so we got yeah. Right. You just take the bottom number, set it equal to 0, and solve it. That's it. Yeah. And then that's it. So exactly. And that's it. Yeah. I mean, if y'all want to stay back after class and do homework, please. You know? Y'all could do it on your phone. You could do it in the, what you call it, on the computer. So I'm looking at C now, right? I got x plus 4 divided by x squared plus 5x, yeah, plus 6, right? So what am I going to do here? I'm just going to set this thing equal to 0, right? The denominator. So what do I have? I have x squared plus 5x plus 6 equals 0, right? And just solve for x. Solve for x. I'm going to factor this. Equals 0. I know this is x here, and I know this is x here. I need two numbers that when I multiply them will give me a positive 6. And when I add them together will give me a positive 5. What are they? 6 times 4? No. Not 6 times 1. add to 5, but multiply to 6. 2 times 3, right? So plus 2, because this is a quadratic, so we have to factor it out. That's why. Yeah. Not that bad though. So after that, same thing as before, right? I'm gonna set both of these equal to 0, right? I have x plus 2 is equal to 0, and I have x plus 3 is equal to 0. To solve for x, minus 2, minus 2. So I have x1 is equal to -2, and minus 3, minus 3. So I have x2 is equal to -3. Right. So basically what this is telling me, in this expression, I could plug in any value I want for x, except -2 and -3. Right? That'll be true, right? These values will make it false. And that's it. Here, you guys try one. Same thing as before. Try that out. What I'm asking here is what value for each one individually would make the denominator or make the rational expression itself undefined, right? Or would make the denominator 0. That's what I'm asking. Like, hey, yeah. So they just easy, just 0, 0. Like I was saying though earlier, we reach a point in the class now where the homework is gonna be less, you know? Yeah. So just letting y'all know that, like, so you know, this that time to catch up now. Yeah. It's okay, you got time. Time, just come through. Yeah. Mhm. Yeah. Right. That time will catch you. Yeah. Yeah. Got you. At first it was a lot, but at first it was light though, right? Was 2 plus 2 was 8 minus 3. Got you. You have to multiply to 3 and add up to 4. Yeah. So the C term is multiply and the B term is add up. All right, let's take a look. I'm gonna start off with the hard one, A. What's the answer? What? Huh? Yeah. E? No. 0. That's the answer. Right, so remember, 8x equals 0, divide by 8. You know. Mhm. Let's look at, how about B? What's that? N equals -1/3. Good. Right? Mm-hmm. What about C? That's the easy one. Huh? -3. Right. Where the 3 come from in B? Right, so, oh, the 3 I don't care about. It's the denominator, the bottom part, right? So just take the 8, take the 8x for A, and set that equal to 0. And then just solve for it, right? Divide by 8, divide by 8. So you have x is equal to 0. This is the legal number. That's what I'm looking for. Yeah. Oh, you mean like the top, like 3y? I don't care.
Everything's the bottom, that's all that.
Right. Yeah. I need to set the bottom equal to 0 because I want to know what's illegal here. Yeah. All right. Any questions on this? C, got you. So for C, right, I had a squared plus 4a plus 3, right? And then what I did was I wanted to factor it, right? So I knew this would be like a and a right here. And then I needed two numbers that multiply to give me a 3. But when I add them together, give me a 4, right? So then that's going to be 3 and 1, right? And they're both positive, so +3 + 1. But here's the thing though, right? I got to set them equal to 0 individually. So a plus 3 equals 0, a plus 1 equals 0. And then just solve for it, right? This is called rational expressions. That we're simplifying rational expressions right now. All right, so I'm going to subtract 3 from here. I do the one side, do to the other. So I have a is equal to -3. I'm going to subtract 1 from over here. I do the one side, do to the other. So I have a is equal to -1. And that's it. That's how we did part C. Yeah, so you're gonna see in your homework, right? They're gonna ask you like blah blah blah. What's the excluded value, right? That's another way of saying it. The excluded value is these numbers we're finding here. It's the number that would make the denominator equal to 0. I don't care about the numerator. The number that would make the denominator equal to 0. Yeah. Uh-huh. For which one? Oh, like how to factor it? So got you. So what I'm thinking about when I'm factoring this, right? Because a squared plus 4a plus 3. I want two numbers that when I multiply them together will give me a +3. But when I add them together, will give me a +4. You know? You ever heard that? I got you. So just remember this, like when you dealing with a quadratic, right? Ax squared plus bx plus c equals 0. When you're dealing with a quadratic like that, right? The two terms for your factor, they have to multiply. Forget the a right here. All right, let's call it like that, right? The two factors have to multiply to c. So m times n has to be equal to c, and they have to add up to b. So m plus n has to equal to b. The trouble is finding the m and the n. Right, but that's the secret right there. Hmm? Oh, with the letters? Yeah, I got you. It's like a generalization. Yeah, yeah. But low key though, right? What's on the formula sheet? This thing. Yeah. So if you could read the letters on the formula sheet, then you straight. You know? Yeah. But that's what you're trying to figure out. But you can always play with the numbers on your calculator, you know, until you get it. You know? Yeah. Yeah. Calculator's bomb. Yeah. Yeah. You're welcome. You're welcome. I'm sorry? Say it again. I'm sorry. No, this was just an example. Just answer a question. All right, so that was finding the excluded value, right? So that's a part of the homework, right? But the real homework right here that we're gonna be, or that you're gonna do, is simplifying the rational expression. So a fraction is considered simplified if there are no common factors other than one in its numerator and denominator. So similarly, a simplified rational expression has no common factors other than one in its numerator and its denominator, right? So it's the same thing that we were doing before, reducing a fraction, same stuff. Let me just give y'all an example real quick. So for example, let's say I have x plus 2 over x plus 3. It's simplified because there are no common factors of x plus 2 and x plus 3. But say I have like 2x divided by 3x, right? 2x divided by 3x. It's not simplified because x is a common factor of 2x and 3x, right? I'd have to reduce it by canceling out the x's. Then I have 2 over 3, and then that would be simplified, right? So, and that's just one. I'm gonna get to that though. I'm gonna get to that. Yeah. 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 But real quick, let's go back to the letters real quick. That's what's on your formula sheet. So equivalent fraction property, right? If A, B, and C are numbers where B cannot equal 0, C cannot equal 0, then A over B is equal to A times C over B times C, and the reverse. A times C over B times C is equal to A over B, right? So we're going to be using that when we answer our questions. All right, so to simplify rational expressions, we first write the numerator and denominator in fracted form. Then we remove the common factors using the equivalent fractions property. Be very careful as you remove common factors. Factors are multiplied to make a product. You can remove a factor from a product. You cannot remove a term from a sum. Really important. You cannot remove a term from a sum. I see that mistake often. All right. I just want to elaborate on that mistake a little bit. Just so we're clear. All right. So let's say I have a fraction and I reduce it to its basic prime factors. 2 times 3 times 7 over 3 times 5 times 7. Cross out the like terms in the top and the bottom. 3 and 3, 7 to 7. Whatever's remaining, that's your simplified fraction. So 2 over 5, right? And that's it. Let's say I have 3x times x minus 9 over 5 times x minus 9. X minus 9 is common in both the top and the bottom. I'm going to cross those out. Whatever's remaining, the 3x over 5, that's your answer. That's a simplified fraction. But look at this though. I have x plus 5 divided by x, right? I cannot cross out the x's over there, right? I can't do this. I can't say, oh, there goes x, there goes x. I can't do that, right? X plus 5 over x is the most simplified version of it, right? So let me just read this. While there's an x in both the numerator and denominator, the x in the numerator is a term of a sum, right? So this is the final answer. Nothing else left to do, all right? I see this mistake often, just wanted to elaborate on it. Hey, how are you? All right, let's take a look. So the instructions for this question are to simplify, right? Which is not that bad. So I'm gonna factor the numerator, factor the denominator, cancel out the like terms, and then whatever's left over, that's my answer. That's it, right? Let's take a look. I'm gonna do the top, and then I'm gonna do the bottom. So looking at the top, I have x squared plus 5x plus 6. Let's factor that. Give me two numbers, right? That when I multiply them together will give me a 6. But when I add them together, give me a 5. Okay?
Why you gotta do it like that? One's above you, not this.
That's before. So before I was asking you what would be the excluded values, right? The value that would make it illegal. In this situation, I'm trying to simplify the fraction. Okay?
Those ones you not do it.
Because they're done for me right here. That's what I'm trying to get to.
Also, like, those are not like, those like bigger problems.
Nah, we're just breaking it down to make it simpler, right? Simplifying, right? Not too bad. So look, for the numerator, the top number, I have x squared plus 5x plus 6. Give me two numbers, and when I multiply them, will give me 6. When I add them together, give me 5. You have to multiply the 6, but add up to 5. 2 and 3, right? So this will be x plus 2. This will be x plus 3. Now I'm looking at the bottom, right? I need two numbers, and when I multiply them, will give me a 12. When I add them together, will give me an 8. What do you guys think? 4 times 4 is 16, though. 4 and 3.
2 and 6.
2 and 6.
Yeah, this is like a fucking game.
2 and 6. That's it, right? Because 2 plus 6 is 8. 2 times 6, 12, right? Now, notice, I got an x plus 2 in the numerator, and I got an x plus 2 in the denominator. So what am I going to do? I'm just going to cancel those out. So what am I left with? This is my final answer. X plus 3 over x plus 6. And that's it. That's my final answer. Simple, simple, simple. All right? Just cross out the like terms. All right, I'm gonna give y'all a harder example. You guys try this. Bless you. It's a little bit harder, but I think y'all could get it. Back to the top, back to the bottom, cross out the like terms, and then that's it. So, yo, how about that New York Liberty win? Huh? When you factor it? No, the subtraction that you're talking about is when you're dividing. I'm not dividing here, I'm simplifying. So factor the top, factor the bottom, and then cross out like terms. Right, so you should have 2 parentheses on the top, 2 on the bottom. Not necessarily, depends on the question. Depends. It depends on the question. Not all the time, not all the time. Yeah. So the top of this one, 2 numbers that multiply to -2, but add up to -1. Yeah. So you want 2 numbers that multiply to give you a -2, When you add them together, it'll give you a -1. I mean, there's only two numbers that multiply give you 2. That's it. So now play with the signs till you get it for the addition. -2 and -1. Say it again? -1. Add up to -1 and multiply to -2. -2. That's it. And do it's not so bad. Probably, I don't know. The next topic is even easier than this. So it's not. Use the AC method. But you got the calculator. Just pick it through. All right. See, I heard this with 2 little numbers, you go negative. I was like, I mean, true. All right, let's try it. So I'm looking at the numerator, right? What we got? Yeah, so we have x what? Say it again. That's not to get the answer, it's just a factor. For the top. What's the numbers? Huh? +1? And what else? Not +2. -2. All right? Huh? Because 1 plus -2 is -1. I need that to be -1 for you. Right. Hmm? Yeah. So now how about the bottom? A little bit harder. I got an x here, I got an x here. I need two numbers that multiply to +2. When I add them together, give me a -3. You can even look at the signs, right? That's a +2 in the denominator, right? So the only way I can get a positive number from multiplication is if both numbers are positive or both numbers are negative, right? Looking at the B term, the middle, is actually negative. That's a -3. So I know that this is going to be what? A negative and a negative. So what's the number? What two numbers multiply to give you 2? -1, -2. And that's it, right? After that, I look at it, I got an x -2 on top and an x -2 on the bottom. Just cross them out. What am I left with? Over x -1, right? That's my answer for this question. That's it. Questions on that? Make sense? All right. There's a couple of questions for homework, that y'all could try. We'll give y'all a little bit of procedure before we continue. So how to simplify a rational expression. Step 1, factor the numerator and denominator completely. Step 2, simplify by dividing out common factors. That's it. 2 steps. Let's look at this example. Might look crazy, but it's doable. Right? It's doable. All right, what's the greatest common factor in the numerator? 3, right? What am I left with? Minus 4 AB. So perfect. Divided by, what about the denominator? 6. What's left over? Hmm? Minus 4. It's good. All right. So now I want to factor the numerator and factor the denominator. For the numerator, what do I have? You know, this is A, this is A. Huh? Because of the first term being squared like that. A and A. One thing I noticed is I noticed that my C term here, before B squared, that is a perfect square trinomial. Right? So we already know A and A, 2B, 2B. Both of them have a negative, so negative, negative. Not too bad, right? On the bottom, I have 6. Right? Difference of two perfect squares. What's this? A minus 2B, A plus 2B. Difference of two perfect squares. One is a minus, one is a plus. After that, cross out your like terms, and that's it. Right, and then 3 goes into 3 once, 3 goes into 6 2 times. So I get what? A minus 2B over 2 times A plus 2B. That's that. Questions on this? We reduced it. 3 goes into 3 once, 3 goes into 6 2 times. So that became 1 over 2. Right, to the bottom. Questions on this? Right. I'm sorry? How much chapters? Couple more minutes. Good. Good. If y'all wanna take 5 minutes, go ahead. Give y'all another 4 minutes. All right, let's take a look at this one. So I got 2x² minus 12xy plus 18y squared, right? What's the greatest common factor there? What do we think? 2, right? So we'll factor out of 2. What's left over? I got x² minus, what's this? 6xy plus 9y squared, right? Over denominator. What's the greatest common factor there? 3, right? What's left over? X² minus 9y squared, right? And then let's factor this. So what's on the top? So XX, because of the x squared right here. So it's x times x is x squared. Yeah. The 6, we didn't do that yet. Perfect square trinomial, right? So we know this is 3y, 3y. The 6, when you distribute it out, you get back to 6. But I'm trying to do the reverse. I'm trying to factor. Right? What about the bottom? X² minus 9y squared. What's that? Difference of two perfect squares, right? X plus 3y, x minus 3y. And that's it. Knock out the like terms. And whatever's left over is my answer. 2 times x minus 3y over 3 times x plus 3y. That's it. Questions on that? Moral of the story, factor the top, factor the bottom, cross out the like terms. All of it. Yeah. Got you. All right. Let's keep it moving. So I want to talk about a very special situation right now. Okay. Same topic as what we're doing, but a special situation. So we're going to talk about opposites in a rational expression. So the opposite of A minus B is B minus A. So if I have A minus B divided by B minus A, that's equal to -1, where A cannot be equal to B, of course, right? So an expression and its opposite divide to -1. That's that. Very special situation. Let's take a look at an example. So let's say I want to simplify this, right? I have x² minus 4x minus 32 over 64 minus x². So I want to factor this. On the top, I need two numbers that multiply to 32. But when I add them together, we'll add up to -4. Excuse me. Multiply to -32. Sorry about that. And when I add them together, I will add up to -4. So we know this is x and x. 32, what do we think? 8 times 8 and 4, right? -8 and +4. That's very good. Right, -8 plus 4, that'll give you a -4. -8 times 4, that'll give you the -32. I'm looking at the bottom now. I have the difference of two perfect squares. That's 64 minus x squared. What does that become? That becomes 8 minus x squared and 8 plus x squared. Right? Yeah. Oh, yeah, for you, yeah. You know where the elevator is? Right, so it's like diagonal to the elevator on the left hand side. Yeah. Like, so if you're looking at the elevator, you just go diagonal to the left. That'll be it. You're welcome. Yeah. So I got x minus 8 times x plus 4 over 8 minus x squared times 8 plus x squared, right? Now notice, x minus 8, right? And hold on. I'm sorry, I shouldn't have had those squares there. Apologize. Typo. Notice the x minus 8 and the 8 minus x, right? They're opposites. They're opposites, right? So because they're opposites, I know that this is going to go to -1. So what's my final answer? My final answer is actually negative x plus 4 over 8 plus x. So anytime you have opposites, they simplify down to -1. That's the trick here. All right. Anytime we have opposites, they simplify down to -1. Let me let you guys try one. Try that out.
squares into.
Let's take a look. This one's not too bad. So I have x squared minus 4x minus 5, right? I want to factor this. So for x squared minus 4x minus 5, I need two numbers that multiply to give me a negative 5. When I add them together, it'll give me a negative 4. What do we think that is? Say it again. Minus 4, not minus 4. Plus 4? What two numbers multiply to give you 5? 1 and 5, right? So what are the signs there?
Plus 5.
Not plus 5. Negative 5. And what else? And plus 1, right? Because 1 plus negative 5 is negative 4. And 1 times negative 5 is negative 5, right? Denominator now, I have 25 minus x squared. What's that? 5 minus x and what else? 5 plus x, very good, right? So now I notice, right, that the 5 minus x and the x minus 5 are opposites, right? They're opposites. So these two are going to become negative 1. So I have a negative on the outside here. And then I have what? X plus 1 over 5 plus x. And then that's it. Questions on this? Good. All right, all right, all right. Let's just switch things up a bit. Let's talk about multiplication. It's going to be real simple. So multiplication of rational expressions, right? If P, Q, R, and S are polynomials, where Q cannot equal 0, S cannot equal 0, then P over Q times R over S is equal to P times R over Q times S. So to multiply rational expressions, you multiply the numerators and multiply the denominators together. So just multiply straight across. That's it. Right? And that's how we multiply rational expressions. Nice and simple. So here's an example. We're asked to multiply this rational expression, or more specifically, to simplify. Right? So what am I going to do first? I'm going to factor this first. Right? So I have a 2x up here. On the bottom, I have a what? X. The two numbers that multiply to give me 12 add up to negative 7, 4 and 3. So negative 4, negative 3 times. Over here, I'm going to factor the top, factor the bottom, so this is gonna be x minus 3, x plus 3, right? All over 6x squared, right? At this point, I want to cross out the like terms, right? I can cross out diagonally, or I can cross out up and down. Diagonally, I have x minus 3, x minus 3, right? Diagonally, I also have, right? I have 2x here, so go to 1, and this would become 3x, right? Because the 2x goes into 6x squared 3x times. Like I'm reducing it, right? And then once again, to multiply a rational expression, multiply straight across, numerator with numerator over denominator with denominator. So 1 times x plus 3 is just simply x plus 3. Huh? Wait, why do we get rid of the what? The 2x, because 2x goes into 6x, right? 3x times. Yeah. And then now on the bottom, I have what? I have the 3x times the x minus 4. That's it. That's how you multiply rational expressions. So you're gonna simplify it before you actually multiply it. And when you do multiply it, numerators with numerators, denominators with denominators. You don't need to distribute it after, you can leave it factored like that, and that's the right answer. Questions on it? If not, let y'all try. Try that out. Sorry? It can't be a larger number? No, I don't get it. Ask it. If you only factor out the larger number? That's it. Yeah. Let's take a look. So I have 5x up top. I'm factoring the bottom, right? So I have x. What? Two numbers that multiply to 6 but add up to 5. What are they? 2 and 3, right? So plus 2 plus 3 times, what's the factor of the top? Right? Perfect, perfect, perfect. All over 10x. Then after that, cross out the like terms. I have a positive 2 here and a positive 2 here. I have 5x, which goes into itself once, and 5x goes into 10x 2 times. Final answer is what? X minus 2 over 2x plus 3. The 2 and the 3? Yeah. You still got the right answer? Okay. Yeah. All right, as long as you get the right answer, that's all that matters. All right. All right, before we continue, let me just give y'all a little bit of notes real quick. Give you guys a little how-to. All right, so to multiply rational expressions, step 1, factor each numerator and denominator complete. Step 2, multiply the numerators and denominators together. Step 3, simplify by dividing out the common factors. This is how we multiply rational expressions. If anybody wants to copy that now. All right. Let's try this one out. It's the same game as before, right? Factor the top, factor the bottom. But I got a number in front of my x squared term here. So we got to use the AC method, right? We're going to use the AC method. So I'm looking at the 3a squared minus 8a minus 3 question, right? So AC method, right? A times C is equal to 3 times negative 4. Oops. Excuse me, wait, 3 times negative 3, I'm sorry. A times C, right? This is my A. This is my C. This equals negative 9. My B is equal to negative 8. Now I need two numbers that when I multiply them will give me a negative 9, but when I add them together will give me a negative 8. What do we think? Right, multiply to negative 9, and when you add them together will give you negative 8. Well, reverse that, -9 times 1. Give me -9 and then -9 plus 1. This is also, this is -8. Right? So now, let's rewrite it. I have 3a squared minus 9a plus 1 a minus 3. After you do that, group them together because we have 4 terms, right? Greatest common factor, 3a squared minus 9a is going to be 3a. Leaving back just a minus, what's that? 3. Then we have 1 plus, well, excuse me, 1a minus 3, right? Okay. Greatest common factor there is +1, right? Leaving back a minus 3. I'm sorry? Where? The factors are -9 and 1, so like positive. That's what a plus came. After that, factor out the a minus 3. I leave it 3a plus 1 equals 0. Next, I want to do a minus 3 equals 0. And 3a plus 1 equals 0. Solve for a. So I have a1 is equal to 3. Right? And over here, I'm going to subtract 1. When I do the one side, do the other. Right? Then we want to do what? Divide by a. By 3, excuse me. Right? So a is equal to -1/3. So let's put those in. A plus 1. Bottom, a plus 5. A minus 5. Top up here, this is going to be what? A plus 5. This is squared over UAC method. This question is involved. I have 3 times -5. This equals -15. My B term is what? -14. So 2 numbers that multiply to -15 add up to -14. What am I gonna have? Thinking -15 times 1 and negative 15 plus 1. So you get negative 14. Rewrite what we have. 3a squared minus 15a plus a minus 5. Factor by grouping. Group these two together. Greatest common factor is 3a. What's left over? Right? This is going to be what? A minus 5. And over here, plus 1. A minus 5. Greatest common factor one more time. A minus 5 times 3a plus 1. A minus 5. 3 a plus 1. It is on homework. Yeah. Let's cross out them like terms, right? So I have the plus 5 here. One of the plus 5s there. 3a plus 1, 3a plus 1, right? And that's it. That's all I could do. So I'm going to have what? A minus 3 times a plus 5 over a a minus 5, a minus 5. That's it. Questions on this? This one was a little involved. But the story behind it is the same. Factor, cross out the like terms, multiply straight across, that's the lesson. No questions? All right, here, try one. Remember, factor the top, factor the bottom, cross out the like terms. No problem.
This way.
It's perfect. It's perfect. Yeah.
It is like that.
Yeah, it's in not the last announcement, the one before it. It's on the bottom, like a little PDF to download with it.
Okay.
Yes, you can look at that before the exam.
Thank you.
See you all. You guys got it already, or you need a few more minutes? All right, I got you. Just a hint. Each one got two parentheses. All right, so how about now? You good? What's our factor for the top? What we got? All right, let's go through it then. I'm doing the AC method. This is 2 times -12. Gives me -24. I have my B term, which is 5. I need two numbers that multiply to give me a -24, but when I add them together, give me a 5. What do we think? Well, we know that the only way to get a negative number, right, from multiplication is if one number is negative, one number is positive. My B term over here turns out to be positive, so the bigger number that I'm looking for is going to be positive. All right? 24, some ideas that come to mind. I'm thinking 6 and 4, but that doesn't seem to work. What else we got? 4 is 2 and 2. 6 is 3 and 2. Some combinations of those prime numbers right there. How about 8 and 3? That looks pretty good, right? Bigger number positive. 8 times -3. That's -24. 8 plus -3. That's +5. All right? So let's rewrite this. I have 2x squared plus 8x minus 3x minus 12. Let's group these together. Greatest common factor here is what? 2x. That leaves back what? X plus 4. Greatest common factor on the other end is going to be -3, leaving back what? X plus 4. Factor out the x plus 4. I'm left with 2x minus 3. So I have 2x minus 3 and x plus 4. All right. Over here, I have x squared minus 8x plus 16. That's a perfect square trinomial. So we know this is going to be what? X minus 4, x minus 4, x squared minus 16. You know that's going to be difference of two perfect squares. So x plus 4, x minus 4. All right, AC method on the last one. So I have 2x squared minus 13x plus 15x. Excuse me, minus 13x plus 15. We're going to do the A times C. That's going to be 2 times 15. Let's call that 30. My B term is -13. So I need two numbers that when I multiply them will give me a +30. When I add them together, give me a -13. Right? +30, we know is going to be what? Two negative numbers. That's the only way to get a positive number through multiplication. So 30, I'm thinking what? For me, I'm thinking about 15 and 2. But I know 15 can get broken down a little bit further. 5 and 3. Now I know that some combination of this is going to add up to 13. So I'm thinking. 6 and 5 is 10, 11, can't be. Right? 10 and 3. 10 and 3, that's it. Right? So if I have negative 10 times negative 3, that's gonna give me a positive 30. And if I have negative 10 plus a negative 3, that's gonna give me a negative 13. That's simple. So let's rewrite what we have here. Right? Just get a little bit of space real quick. So I have 2x squared minus 10x minus 3x plus 15. I want to group these together. On my left-hand group, I have 2x squared minus 10x. Greatest common factor there is 2x. What am I left with? X minus 5. Right-hand group, I have negative 3x plus 15. Greatest common factor there is negative 3. What am I left with? It's going to be x minus 5. Factor it out one more time. X minus 5. I'm left with 2x minus 3. So x minus 5, 2x minus 3. Okie dokie, cross out the like terms, right? So I have x minus 4, x minus 4. I have 2x minus 3, 2x minus 3. I have x plus 4, x plus 4. So what am I left with? Final answer. X minus 4 over x minus 5. Simple, simple, simple. All right? That's not too bad. All right, last topic for the day, right? Before I get into that, let me just see something. All right. So we spoke about multiplying. Now we want to talk about dividing. Real simple, real quick. So how do you divide rational expressions? So if P, Q, R, and S are polynomials, where Q cannot equal 0, R cannot equal 0, S cannot equal 0, then P divided by Q divided by R over S is equal to P over Q times S over R. So to divide exponents, rational expressions, we multiply the first fraction by the reciprocal of the second. In other words, keep, change, flip. All right? Keep, change, flip. That's what we're doing here. Before I jump into this, I want to give y'all a little bit of notes real quick. A little bit of notes. So how to divide rational expressions, right? Step 1, rewrite the division as a product of the first rational expression and the reciprocal of the second. Step 2, factor the numerators and denominators completely. Step 3, multiply the numerators and denominators together. Step 4, simplify by dividing out the common factors. All right, that's simple. That's how we divide the rational expressions. Let's take a look. Let's take a look. Let's take a look. So I got 6x squared minus 7x plus 2 divided by 4x minus 8 divided by 2x squared minus 7x plus 3 over the x squared minus 5x plus 6. So step 1, right? We're going to rewrite this. So I have 6x squared minus 7x plus 2 over the 4x minus 8 divided by the 2x squared minus 7x plus 3 all over the x squared minus 5x plus 6. All right? Very simply, keep, change, flip, right? Keep, change, flip. So I'm gonna keep the first fraction the same. 6x squared minus 7x plus 2 all over 4x minus 8. I'm gonna change a division to multiplication. For this, I'm gonna use the dot multiplication form because I have x's in this question, okay? And then I wanna flip the second expression that I have here. So this becomes what? X squared minus 5x plus 6 over the 2x squared minus 7x plus 3. At this point, we're back to what we were doing before. Factor, 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 cross out the like terms, and then that's it. Let's do this one real quick. Real quick. All right. So I'm gonna do the first term, right? I want to use the AC method. A times C is equal to 6 times 2, which is equal to 12. B term is equal to -7. Two numbers that multiply to positive 12 add up to -7. I'm thinking about -4, -3. That's 12, -4 plus 3, -3. That's -7. All right. So let's rewrite what I have. I have 6x squared minus 3x minus 4x plus 2. Let's group these together. Greatest common factor, 3x, leaving back a 2x minus 1. On the right-hand side, greatest common factor there looks like it's -2, leaving back a 2x minus 1. Right? Let's write that in over here. So I'm going to have 2x minus 1 times the 3x minus 2, all divided by greatest common factor. This is going to be 4 times x minus 2 times, let's factor the top. The top is going to be what? This is going to be x minus 2, x minus 3, all over. Let's do the AC method on the bottom. So I'm going to have A times C is equal to what? 2 times 3. Call that 6. Now I want two numbers that multiply to positive 6 and add up to -7. That looks like what? -6 times -1. Call that positive 6, and -6 plus -1. Call that -7. Let's rewrite this. So I'm going to have 2x squared minus 6x minus 1x plus 3. Let's group these together. Left-hand group, greatest common factor is what? 2x, leaving back x minus 3. On the right-hand side, greatest common factor, -1. Whoops, wrong way. Leaving back x minus 3. Right? So what do I have? I have x minus 3 times the 2x minus 1. Let's cross out the like terms. X minus 3 is gone. 2x minus 1, 2x minus 1 is gone. X minus 2 is gone. Final answer over here. 3x minus 2 over 4. And that's it, right? So long story short, we're dividing rational expressions. Keep, change, flip. All right, keep, change, flip. All right. We'll let you guys try one. Go ahead, you guys try this out. While y'all doing that, I'm gonna try and hand back this test. Give y'all a few minutes to. Next one. November. Oh, that's fine. This would be like one question or two. This is. Well. Meetings. 75 is a great. Right, Philip? You could go back. Yeah, you get like half the points back that you missed. So Emily. Junior.
Hey, you like what that is? They got go like red numbers. Easy.
John.
That's Parker.
Yeah. Alpha. Y'all. Darlene Vega. Paulina. Not bad. Let's say go soon. I give you like half the points. Franklin. Franklin Yaguchi. Vasquez. John Vasquez. Michael Vasquez.
Hey, they said we can work this course.
Situ G. Katina Means.
I did the worst.
So. Gotcha. Like I said, you get back half the points that you missed. Like on two, you know? So you figure like, well, no pressure, like, let's give back. You get back to me next week after what?
I get back to, well, all this like on the tutor or something?
So go to tutoring, right? Go to any other tutor other than me, right? Because you already heard how I, so I want you to hear how somebody else, right? So then like just whatever question you got wrong, just do it with them and then get their signature also at the end of it. Bring it back to me and give back half the points for this. So you figure if you got like a 50 on this test, right? And then you go to tutoring, right? You give back half the points, that becomes a 75.
Oh, I got 72. But that.
You're gonna have like an 80 something.
I got it.
Also remember, I dropped the lowest test score, so you know it might be like an 85. That might be the lowest test scores. The website is BCC. Google BCC and WC.net. Three sites that I highest rated. It's so weird.
Yeah.
But I mean, if you don't go to tutor, then because
I also pull up, I gotta get my car. Well, I ain't gonna change that first.
so November, some November. We got a couple more topics before we ready for next. I guess.
Yeah, I should work on this one, it's not even one that's.
Question on that subject?
You don't got that question, or you got more question?
I'll be like,
Um,
son is better for you though. You're
Yeah,
missing
it's
this one
fine.
video.
It's what's going on.
Oh,
So we got one day like before the test, we got like a little reviews.
I posted it, man.
We got to do it. We got-
So another thing too, though, right? It's this I want to say it's Friday, right? Gotta post like midterm grades, right? Just want to let y'all know, like I did do the midterm grades already, right? Just taking into account whatever homework you've done up to a certain point, right? This is not your final grade. It's just some formality thing that we have to. All right.
This is what happens to right here.
No, so like.
Yeah, it's
So
like.
You ever think people that you do it, right?
Yeah.
I never used that about it.
Yeah.
Just know though, like, when you see that grade, like, that's not your final grade, right? It's just like a little progress kind of thing, alright?
So like, I don't watch it a little, I mean, it's hard.
It's based off the homework and it's for test, right? But here's the thing though, right? Remember, I'm dropping the lows. I'll get half the points back that y'all, this and all of that, so it's probably gonna be higher, like, after the grade comes out type of nonsense, right? So like, don't think it's a hard, you see.
I hope I said, I wanna see that Pfizer, or you know,
Yeah,
still like see Pfizer every time you come here, but
for real.
I never got one.
But you radiology though, right?
Yeah, I was certain, I didn't need a Pfizer, I think my surgery, I
Yeah, I got you. On the fourth floor, there's a lady up there, her name is Alicia, that's your advisor. On the fourth floor. The same building. Huh?
For the mat.
No, for radiology.
Oh, for kids, okay.
Yeah,
Okay, that's.
yeah. For you go to Meister.
this building?
The same building, yeah, fourth floor, yeah.
Like Alicia, where are you?
Yeah, Alicia Hernandez, that's her name. Yeah,
Where are you?
yeah. I mean, after class, if you wanna go check, see what you did.
I got this for months, I got to put it on.
Oh, got you. Got you. All right, let's take a look at this, right? Last problem. So again, right? I want to rewrite this, in a traditional format, right? So I'm gonna have 3x squared plus 7x plus 2 over the 4x plus 24 divided by the 3x squared minus 14x minus 5 all over the x squared plus x minus 30, right? So what do I want to do here, right? I want to keep, change, flip, right? Keep, change, flip. So I'm going to keep the first fraction the same way. This is going to be the 3x squared plus 7x plus 2 all over the 4x plus 24. I'm going to change that division to multiplication. In this case, I'm going to use a dot multiplication because I have x's in this problem, right? And then I want to flip the second equation. So I have the x squared plus x minus 30 all over the 3x squared minus 14x minus 5. And then what do we want to do after that? We want to factor these, right? So I have 3x squared plus 7x plus 2. Let's see, what is that? Feel like this is going to be 3x. Just to save time, because I know y'all trying to get out of here. Feel like that's going to be 2. That's gonna be positive, that's 6 plus 1. Factor this out, that's 4. Call that x plus 6 times over here. We got the x right here, 2 numbers to give me 30. I'm thinking 6 and 5, so positive 6, negative 5. Down at the bottom, I got a 3x here. I got x over here. I'm thinking that this is gonna be 5. I'm thinking that's negative. I'm thinking that this is gonna be a positive 1. Okay. If you can't do it in your head, it's okay. AC method will always work. Very simply right now, cross out the like terms. I have a 3x plus 1, 3x plus 1. I have an x plus 6, x plus 6. X minus 5, x minus 5. Whoops. Let me do a better line than that. All right, boom. So what am I left with? X plus 2 all over 4. And then that's my full answer right there. All right, any questions on this? All right, if y'all, got you. If you ain't get a chance to do the test, reschedule with me. I'm in person in the lab on Monday, Friday, and Saturday. Just book an appointment and come see me, and you guys can take the test. Right? All you need is your calculator. All right, go ahead. On the tutoring website. Yeah, you know when you go into tutoring, the announcement, that link, that's where you can book it. Like I'll show you before you leave.
Calculator?
That's it. Just bring your calculator and you're good.
Alright.
Yeah, and a pen. That's what we got scrap paper law, so you gotta worry.
Does the advisor go up?
Huh?
And the categories will go up?
Yeah. So when you go to tutoring, right? You're gonna work with the tutor, right? You're gonna do all the questions that you got wrong.
There was
Right.
only one problem, they kind of.
It's fine. Do whatever is, if it's blank, do it. If it was wrong, then just do the wrong question, right? And then whatever when you come back, I'll give you back half the points you used. Is everybody done with this? Can I turn this off?
Yeah.
All right. So to everybody watching the recording, have a good night. Talk to y'all another time. All right.